In this lesson, we're going to introduce logarithmic functions. And the first thing I want to do is let's go back and take a look at an exponential function before we even talk about logarithms. An exponential function is in this form right here. And you notice for an exponential function that the variable x is in the exponent. Okay, so in, I think it was chapter 6, we talked about inverse functions. And every function does have an inverse, and every relation has an inverse. Let's talk about the inverse of an exponential function. The first thing you do to find an inverse, remember, is you switch your two variables. So we have x equals 2 to the y. And then the next thing we do is we solve for our y variable. In this case, our y variable is now in an exponent, and it's very, very difficult to solve for it. In fact, it's impossible to solve for this variable. So they came up with a function called logarithm, which represents this variable being solved for. So this statement right here, if we wanted to solve for y, we would write y equals the log of 2, this base right here, and that equals x right here. Okay, so these two statements right here, this logarithmic statement and this exponential statement are the same thing. The only difference is that when we write it in logarithmic form right here, we're solving for a variable y as a function of this original exponent up here. Okay, so logarithms are inverses of exponential functions, and the answer to a logarithmic function is actually the exponent right here. Okay, so we can say, what exponent do we raise the number 2 to get x? Well, in this equation, you can see we're raising the number 2 to the y power to get x. Okay, so your answer is always, if you take a look at the exponential function, your answer is always the exponent that you would come up with. So let's get started on logarithms and how to change a logarithm from this form into this form and then back again. We're going to take an exponential equation like this and we're going to change it into a logarithmic equation, and let's see if it makes sense. But before we do it, I want you to pause the video and I want you to take your notes. Okay, so let's come back and let's go ahead and convert from our exponential form to our logarithmic form, and then we'll convert from a logarithmic form to our exponential form, and let's make sure things make sense. All right, so here's our first example right here. We know that 10 squared is 100. How could we convert this statement into a logarithmic form? Well, it says up here in our notes that if we have an exponential statement here, b raised to the y power equals x, that converts back into our logarithmic form in this fashion. Our base b in our exponential is now going to be our base b in our logarithmic form. Our exponent is going to be the answer, and this x value here is going to be inside with our logarithm. So let's locate our base first on our exponential side. Here's the base of our exponential equation. So we're going to say log, and we're going to say base 10. Okay, now what goes in here? What goes in here is the answer. What is it equal to? It equals 100. So that 100 goes in here, and we'll set it equal to the exponent. The answer to a logarithm is always the exponent. Always, always the exponent. So let's take this example here and let's convert it to logarithmic form. First thing we do, oops, I forgot the O, is we locate our base in our exponential function. Let me go ahead and rewrite this again. And we write log base 3. I know my logarithm is always equal to my exponent, so I'm going to write 4. The only number that's left is 81. And we can read this as log base 10 of 100 is 2. And I know that's true because base 10 10 raised to the second power is 100. 3 raised to the fourth power is 81. Let's go ahead and convert this one. This one looks a little bit more difficult, but if we locate our base is 2/3, so that is the base of our logarithm. The exponent, since our log always equals an exponent, it has an exponent of 3, so our logarithm is going to equal 3. The only number left is this 8/27, and that goes here. So 2/3 raised to the third power is 8/27. Now let's take a look at this last one. We have log. What is our base going to be? Here's our base over here in our exponential function. It's going to be base 3. What was our exponent in our exponential function? 0. The answer is going to be 1. 3 raised to the 0 power equals 1. So let's go ahead and take a look at how to convert from logarithmic form back into exponential form. So again, the very first thing we're going to do is we're going to identify our base. Our base is 2. And where's our exponent? Our logarithm always equals an exponent, so our exponent is 4 in this case. 2 to the fourth power equals 16. Now let's go ahead and take this logarithm, convert it back into exponential form. Here's our base here. We're going to write 1/2. Since it is a fraction, I'm putting it in parentheses. Where's our exponent for a logarithmic equation? It's what it's equal to. So it's -5, and that's going to equal 32. Lastly, let's convert this back into exponential form. Here's our base of 4. Our logarithm always equals an exponent, so here's our exponent. 4 to the -3rd power is going to equal 1/64. Okay, so you guys need to go ahead and practice converting logarithms back into exponential form and exponential form back into logarithms so that you can easily do this when we start solving logarithmic equations.